Is it possible for an electron to be two places at once? Or for a cat to be both alive and dead at the same time? According to quantum mechanics, both scenarios are possible. And at the heart of this conceptual dilemma lies the wave function, the mathematical formula that we use to describe quantum objects. To see the wave function at work, let's take the case of an electron shooting out of the back of a cathode ray tube, a device found in the back of old-fashioned TVs. The wave function for this electron is just a description of where the electron is and what it's doing. For example, how fast it's going. To predict where the electron will be in the future, you just plug the wave function into Schrödinger's wave equation, the quantum equivalent of Newton's laws of motion. But here's where it gets tricky. The wave function isn't a regular number. It's a complex function that relies on imaginary numbers, such as the square root of -1. And it gets even worse. The wave function can only give you a statistical prediction about where the electron will be in the future. It's a statement about probabilities, nothing more. If you took two electrons with the exact same wave function and looked to see where they are, you might find that one is over here and the other is over here. And worse yet, once you observe an electron, detecting it in this place and not in this place, the wave function immediately and irreversibly changes. Physicists say that it collapses from a broad range of possibilities to one specific answer. Think about that for a second. The act of measuring the electron is what gives it its position. And this brings us back to the cat that's both alive and dead at the same time. As it's usually told, a cat and a vial of poison are sealed into a box. Then, a quantum event happens with a probability of 50% that breaks or does not break the vial of poison and kills or does not kill the cat. So is the cat still breathing? The wave function reflects both possibilities. In the standard interpretation of quantum mechanics, both possibilities are real. The cat is truly both alive and dead until an observer opens up the box. At this point, the kitty collapses into either an alive or a dead state. This is absurd, of course. Cats can't be both alive and dead at the same time. So how do we get out of this paradox? One of two ways. Either the wave function doesn't really exist, it's just a reflection of our knowledge, or the cats are both alive and dead, but in two parallel universes. For Scientific American's Instant Egghead, I'm Michael Moyer.